Yeah, hello. My name is Valentin Heun. I'm leading the PTC Reality Lab. That is a selfie of my team. It's Anna and Hisham and Christian and Benjamin. They're all extremely gifted engineers and designers. I'm so happy that I have the ability to work with them. And so a lot of what I'm gonna show you in this talk, they're like the superheroes behind it. So just want to mention that in the beginning. So this talk is about a third stage of augmented reality user interfaces. And in order to tell why there are three stages, I want to go a little bit through them. And the first stage I would call, oh my God, augmented reality, amazing. And it looks around like this. So it's something that we put into the world, and it looks mesmerizing. We look at it, and we can move a camera around, and it's so much different than a desktop interface. And it connects with us on some interesting, deeper level, but we're not quite aware why. We find it fascinating. But why is it so fascinating? And that, I think, is an important question to lead to all of these stages. So around 2 weeks ago, I attended a talk from our CEO from PTC, who is a very innovative and visionary CEO. I think he's actually one of the key innovative players in our industry. I'm not saying that because he's paying me, but that's the reason why I joined PTC. And he talked about something like a HoloLens, actually a human modem. That's a really interesting point. It's like you put this thing on your head and you become connected. The computer knows where you are, and you put all of this data into your head through that modem. But when you look at a real modem, you have all of these data processing units in the modem. You have protocols that allow you to run faster and faster and faster. And so we had these human modems for a long time. We call them personal computers, and then we call them smartphones and so on. But usually they don't really connect with all of these processing units in our brain. So they allow us to use the object recognition. That's already a big advantage. But then there's more. And so I'm really interested in increasing the data throughput through that modems, through that channel. And so we started with the terminal. There were no object recognition. That was reading letter by letter. And then we got into this desktop paradigm, so it really connected well with our object recognition in our brain. But it's not really using the full potential of the brain. So, and that really haunts us when we start dealing with spatial problems. Like, for example, in our office building, I have a printer in front of me, and I want to connect to this printer. And I open that interface that you see here where I'm scrolling. It takes me minutes to find the right printer because there are hundreds of printers in this building, and that is what a desktop interface can deliver. But I'm standing right in front of the printer. It's a spatial problem. I want to connect to that printer. And so augmented reality is that tool that allows us to really connect to all of these processing units in our brain. And the potential for that lies in the spatial. And where that simple, wow, it's amazing demo is so intriguing to us is because it gives us a hint that there is something that we might maybe tap into later. We don't have it yet, but we're going to tap into it. There's research on that. The spatial knowledge allows users to focus cognitive resources on tasks rather than interfaces. There's a lot of work around that. And we have like a guiding North Star since 1991 from Mark Weiser, who really saw a lot of these things at the time, but he hadn't had the technology that we have today. So the most profound technologies are those that disappear, and they weave themselves into the fabric of everyday life until they are indistinguishable from it. So I'm really interested in the highlighted pieces, the weaving, the fabric, and the everyday life. So because for something to weave into everyday life, it really has to connect to all of the senses of our body. It needs to be a full part of our world. And as long as we use a smartphone and as long as we sit on a computer, it's not the case. We will never be able to really put these technologies into our world. So that brings me to the second stage. And that's probably a stage where a lot of you guys here at the conference are currently in. So it is, now that we figured out augmented reality and wow, it's amazing, and then we start connecting augmented reality with some other technological domains, and we use augmented reality to control these domains. And that's a really, really powerful thing by itself. So for example, we combine it with robotics, and we're suddenly able extremely intuitively to drop motion passes on the floor, and the robot starts to follow these motion passes. It's very difficult to program that on a desktop because you need to do the mapping in your mind between the desktop paradigm and the space. I'm just let these videos run. I've seen them a lot. You haven't seen them. Maybe it's interesting. So the next one, for example, is you combine it with big data. So maybe I have allergies in a grocery store, and that tool just allows me to browse through the space. I don't have to take the packages out of the shelf. I don't need to study every package for the allergens that are in it. It allows me a super fast access to data that is relevant for me. I can combine augmented reality with a knowledge base. For example, I can become an origami grandmaster by by supporting me in building origami through augmented reality. There's a really, we had this with a nice soundtrack for Christmas. Ding, 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 ding. So, okay. Or you combine it with speech, and you can have these super intuitive interfaces where you hold it on a person, and it live translates, in this case, from Spanish into English. So you can just hold it on the people you're talking with, and you get speech bubbles for what they say. Another case is you combine it with a digital twin, and you can browse into on any kind of machine or car and have this superpower of X-ray vision into these things. So I would say all of these use cases are somehow alike to what we currently see in augmented reality. We always have a single perspective, a single use case. We look at something, at a problem, and we build a user interface for that. But the interesting part is that we have so many separated realities, so many separated little entities of solutions, but they're not connected. They're all in their little world. They're all separated. And if we really want to make this vision of a spatial computing, or even a spatial operation system, or so on, if we want that really become a reality, we have to start not only look at the individual things, we actually have to start weaving these things together. And we have to start to create one seamless user experience. The same way we have it on a computer with a desktop interface, we have to do the same in augmented reality. And so our mission is to figure that out, to figure out how we can get there and how we can give you that seamless kind of user experience. And that's what we call one reality. Because we want you to live in one reality. We don't want you to be in VR and AR and XR and MR and all the other stuff on that slide. So, okay. So the third stage of augmented reality from our perspective is the weaving. The weaving of these technologies together in one seamless spatial cross-domain user experience. So let's start, for example, with a desktop AR and printer. So Christian here wants to take this rabbit out of the screen, so he just pulls it out of the screen, and he moves it through AR space over to a printer, and he just drops it in the printer. And through that, he has weaved these 2 or 3 different technological domains together into one experience. It's kind of a blueprint for us to say, this is what we think. This is where we are far away from any kind of abstract model of data in a computer. We are truly living in a spatial world. A comparison on the right side, I'm still searching for my printer. Okay. Okay, another one is desktop 3D telepresence AR printer. So here I'm diving into a remote volumetric video of a machine in a factory. So this is live, and he can freely travel around that. It's a little bit pixelated, we're getting there. But he can dive into this box, and through X-ray vision, he can look into the box and see the part inside, and he pulls it out of the screen from that remote place. And he can now inspect it and take that engine piece in this case. He can walk over to a metal printer. Here's the metal printer. And he drops it into the metal printer, and now he's reproducing this piece. So this use case, think about you have a big warehouse, and it takes you 15 minutes to go from one corner to the other. What if you can just dive into some SimCities kind of simulation? You go into your factory, it's all live, it's all 3D, volumetric, you dive in, you X-ray into a machine, you take from a digital twin of the machine, you take a piece, pull it out of the screen, put it in the printer. No more file searching in, all of these folder structures and so on. Sorry. The next one is robotic, augmented reality, spatial programming, and IoT. So we have this robot here, its name is Frida. And we have a user interface that allows us to limit the scale to get the feedback if there's a bin on the scale. And here we have a programming interface in augmented reality. I gave a lot of talks about it. You can look that up online. And so I'm connecting that to an AND logic that is connected to the conveyor. And so Anna, what she does here, she's programming now a motion path for that robot onto the floor. And she's exactly positioning how the robot should be at every of these motion pathways. So, and she places one motion path in front of the robot, and all of these motion pathways are little nodes that are programmable in the system. So not only that she's checking if there's a bin on the robot, but she's now checking if the bin is actually in front of the machine. So now when she activates the robot, she's still programming that session. Okay, so now she's activating the robot. The robot drives to the machine, and it tells the machine, I have a bin on my scale, and I'm now in position, so you please start feeding into me. And so with something like this, we can program an entire factory, all the motions in the factory, all the machines, we can link them all together. We can give one big user experience throughout the entire space. Remote, local, and so on. So it's filling up. You see how it's filling up. It will hit the maximum, and then the machine stops, and the robot will automatically continue, because Anna was able to program that through spatial programming. We can lower, put the sounds a little bit up. So here we have Hisham. He's remote diving into this scene, and it's actually a remote teleoperation co-location scenario here.
The machine so I can see it working?
Yes. So hit the green button.
Oh, I see that the lenses are pouring out. I see that the red light turned on. Can you turn it back off again?
Yeah.
I'm going to go ahead and reprogram that behavior really quickly. I'm going to just click on this node. And then what I'm going to do is I'm going to go to the logic blocks and add an inverter. And then what I'll do is I'll cut that cord and I'll reestablish that connection like so. Now the lights should have a different behavior. Can you go ahead and hit that button and let's see what the lights do?
Yeah, so hit the green button again.
Okay.
Yeah, the green light is on, and hit the red button.
And the red light comes on. Okay, perfect. All right, I'm also gonna program this because I think we can get this to autofill. So I'm gonna do is set this to about 1584 pounds. Click into programming mode. I'm going to connect the output of that weight sensor to the conveyor belt like so.
Oh, awesome.
I see the conveyor belt started to work. I think it'll keep going until it gets to the top of this level. There we go. Right about there. All right, that's pretty cool. And actually, I was hoping that I could. Can you you show us some of the real-time system, I was hoping you could add a chart to this.
Sure, yeah. I'll pull up my reality editor. And, okay, so I see the scale, and I'm going to go and drop in a chart.
Okay.
You see that?
I see that. Thank you.
All right, it's right there.
And what I'm going to do is I wanted to connect, well, there's a sensor up there. I wanted to see, like, let's see if we can see the value of that sensor. Okay.
Oh, cool. I see it has a 4.92 inches.
Yep, I'm also getting that same reading. Cool, and I'll also drop in a chart for you to see as well, because we need to make note to somebody to change out that bin. Hold on 1 second. So I'm going to go into my pocket tool. I'm going to add this. And I'm going to tell everybody using this that this bin needs to be changed up. Can you see that chart right there?
Yep.
Okay. Well, Ben, thank you for helping me reprogram this system, and hopefully there won't be any more problems. All right, see you later.
Thanks.
Okay. So the interesting thing here, I think, is how seamlessly two people can co-locate themselves on the same spot. And Hisham on the remote side can take its own perspective, independent from Ben, co-locating him, co-programming the system. And everything that I've showed you throughout all of these experiments uses one seamless way of interacting with systems. And so we really want to push this further and further, and we want to understand how can we not only for our use case and our applications, but for any kind of application or services or whatever you have in mind, create a seamless experience in the world around us. That's not just a single player, single user, but a multiplayer, multi-user universe in which you can host your own services co-located to anyone else and operate in the world, understand it, control it, and so on. So, I have some more minutes. So, okay, and now we have to scale that. And we've had a couple of talks here where we were talking about operation system for the world or a mirror world that is all around us. We have a lot of thoughts about these technologies, but I haven't heard anything about what is that equivalent of a desktop paradigm in the real world. So that's what we want to contribute. And that's what we have to scale into the world around us. So yeah, we have to scale it. That's the next stage. That's the fourth stage. And I hope in next year or a year after, I can add something to these slides here for next stage. So this is just a little mind map of stuff that's happening in our Reality Lab. Make a little photo of it. Awesome at PTC is an email that you can send us. Connect with us if you have any ideas, if there's anything that you feel like you want to learn more about. We're happy to connect with you. And with that, maybe I go, okay. So if you have any questions, that would be the moment.